Yes,
Yes,
we
we
can
can
hear
hear
you.
you.
Right. Today I'm going to conduct some introduction and, of course, how to do some. Yeah, we'll try like this. First of all, I'll do kind of an introduction on Civil 3D, and then I'll show you how,
Recording in progress.
yeah, how you can do a surface and alignment and a profile using the Civil 3D software, right? So the first thing that you have to understand is, as highway design engineers, we are using many software, either in Sri Lanka or in Europe or America or in Australia, wherever we are using a lot of software, and Civil 3D is one of them, right? So you have to understand that it is a software, so thankfully it cannot replace the design engineer. So that means it is a kind of like developing tool, okay, design tool. So you are able to get the assistance, okay, you are able to get the assistance from the highway design software Civil 3D, but it cannot effectively replace the design engineer. What I am telling you is, now you see in some structural engineers, if you give the loads and if you give the configurations, here comes the result. So these are the number of reinforcements that you are going to use, right? So Civil 3D is not such a software. Okay, of course you have to draw the alignment, okay, but the benefit of Civil 3D is they tell you whether it is a correct alignment or not, whether such a curve is possible at this location or not. Okay, so if you are going to say, I believe that you have studied the basic theories of highway design. Now if you are going to design say a profile curve, you know there is something called, some parameter called k, lv over a, okay, vertical curve length over the modulus of the gradient difference, right? So you know, for particular speeds there is some particular k considered in the side distance or the compatibility criteria or the appearance criteria, there are some k. So once you draw say a vertical curve, it shows what is the k value. So you have to decide whether this curve is going to suit this location or not. That is what basically the Civil 3D software is doing. And the other thing that you have to understand is, uh, this is a big software. What do I mean by big software? Huh? So just think about Word. It's a small software. That means within 1 week, 2 week, you can catch everything. Okay, but Civil 3D is a big software. So that means it takes lot of time and maybe months of hard work to catch everything. Even with the software, you cannot become a good design engineer. Okay, so what you have to do is you have to use the tool of the software for your design. You have to become a good design engineer yourself at first. After that only you can use the tools of Civil 3D software. So we have a very limited time, therefore I cannot tell you a lot of things about it. So we'll start now. What I am going to do is, I have some example drawing. Okay, I think probably that is what you are getting for your assignment as well. So I am going to have kind of like kind of a drawing, that is an AutoCAD drawing, and a data set. So I am going to show you how we are going to create the surface and how we are going to create the alignment and how we are going to create the profile for that. Understood? Okay, any questions so far? Yes, I believe you can hear me, right?
So we can hear you.
Ah, yeah, sure. So you don't have any questions? Huh?
Up to now, no, sir.
Ah, right. So please ask me questions, right? So you can ask me questions in English or Sinhala, no harm. Don't ask me questions in Tamil, right? So I may understand, but I will not be able to answer, right? So anyway, so shall we start then? So I'll check whether I have this share screen facility with me. desktop. Right. So yeah, who is the host here? Can you please give me this sharing privilege?
I made you a co-host. Now you can share it.
Yeah, we'll see. Right. Uh, Now you know, if you just check here, right? Give me a second, right? Right. So now I think you can see two files. One is example survey drawing, and the other one is example points penz.xlsx. Okay. So these are the two files usually you get once you give your survey assignment for a survey. Okay, he gives you this one. What is this? That is an AutoCAD file, and this is file set. Okay, now first thing that we are going to do is we are going to open Civil 3D software. Now please understand that I am having Civil 3D 2018 version. Anyway, it doesn't matter if you are having a year 2020 or 21 or 22, there is no difference. Okay, there are differences, but they are very small. Okay, so we shall open our Civil 3D software. Okay, usually when you are going to open, I think most of you might be having these pirated copies. So of course they can be used for educational purposes as far as I know, but if you are going to do it commercially, you will have to purchase the license, right? So with that, if you are going to open Civil 3D 2018, or even if you are having 2015, it doesn't harm. It doesn't matter, right? So we are going to open Civil 3D. So I'm going to tell again 2018 because that is the version I'm having, right? So we have to open Civil 3D 2018 metric version. Okay, that's better, right? So I'm going to open it. You have to just double click on your computer so you can open Civil 3D 2018. So I think you can see what is in this uh, what is in the screen. That is the default opening screen of Civil 3D, right? So you have to check now first here, check whether you are having this menu bar. Sometimes if it is this hide menu bar is clicked, you don't see anything, right? So maybe you will have to go here and check it is show menu bar, and you have to again check here whether it is Civil 3D. So it can be other versions as well, drafting, annotation, 3D modeling, like that. It should be Civil 3D, right? Right. Now we have to, before starting our design or whatever, right? uh, we will open what? We'll open our surveyors drawing and check. So I'm going to open the surveyors drawing. Okay, desktop, UOM, here example survey drawing. So there comes an error message. This drawing file was saved by an application that was not developed or licensed by Autodesk. What do you want to do? Continue opening DWG file or cancel opening file, right? So this error message comes because this was developed by some software that is not AutoCAD. You know, there are some other software as well, right? So it can be some Bentley's version or whatever. Anyway, this is opening in AutoCAD, but it is not AutoCAD. It is not a software that is developed by Autodesk. So what we do is we just give continue opening DWG file. Yeah, right. Now this is your, you know what is this? This is your rod, right? So you can see we'll identify the rod. This is the existing center line, this yellow color one. These brown colors are tar edges, right? And what is this color? Light brown color. Light brown color, that is I think 30-meter line, because we have asked them to take 30-meter line just because that is our corridor at that time, right? So this is Talduva. Okay, this is Talduva town, right? So now you are supposed to design this road. Just think. Okay, right. Now the very first thing that I am going to do is load my template. So what do you mean by a template? You know, maybe you have good understanding. You know, in Word sometimes you create templates. What is the basic point of a template? Template is, that means you have given the settings as you wish. So every time you don't want to do the same settings. The settings are already stored. Okay. So in Civil 3D, sometimes, you know, when we are going to develop kind of you know, a drawing or something, so maybe some agencies, they use the word chain edge 0, chain edge 10, chain edge 20, something like that. And some road agencies use the word station. Okay, station 0, station 10, station 20, something like that. Both are perfectly okay, but the problem is, at one time if you are going to use the chain edge, and on the other time if you are going to use station, then there comes the problem. It is either chain edge or station. So something like that. So sometimes, you know, maybe our chain edge color is, or chain edge or station color is, say it is blue color, so it has to be always blue, right? So when it comes to vertical curve, we give, say, we cannot give all the parameters, right? So sometimes we'll give, say, we'll give VCL, that is vertical curve length, and sometimes we'll give, say, no, we'll give VCL and K, right? So that is what we are giving as an agency. So that has to be consistent throughout our road design career, right? Therefore, we have prepared a template of our own. Okay, so before doing anything, you have to load that into your software. Okay, so now I am going to load it, right? Now in your case, in your assignment, maybe you will not be able to use this template. So in that case, either you will have to use the default template of Civil 3D, or you will have to prepare one on your own, right? So we'll import file new, and here I have, say, RDA1, here I have highway 1. It is there, but now don't try to check whether that is there in your computer. It is not there, right? So one thing you can do is, just think, we can copy this. Okay, we can copy this, and we can save somewhere. I'll save it somewhere, right? So I'll show you where I saved it. Here it's there. Okay, now if you get this, okay, if you get this, say, you can copy. If I give you this template, you can copy it like this, say copy, and then after that you can go to your software, and you can go to file new, say I'll create another folder, say in UOM, and inside that you can save it. But this template either you have to create yourself or somebody has to give you, right? Otherwise it is not coming on default. Understood? So we are going to open it. Okay, so there comes an error message. This drawing was last saved with an earlier version of the software. Okay, so saving the drawing will, there are some blah blah blah, right? So you can just close. And there comes another error message. Now don't worry much about these error messages, right? Lot are coming. This drawing contains contents created with Microsoft Visual Basic for application software. What do you want to do? What we want to do is continue with the current command, right? So here this is the template. We just loaded the template and nothing we have done so far. So we are going to save it as giving the name file save as, and in this folder I am going to give a name surface and I am going to save it, right? So now you can see there is the sorry, now this is the our template loaded file surface, and this is the example survey drawing, right? You can switch between these two, right? So the very first thing that we are going to do is we are going to copy everything, right? We are going to copy everything and we are going to paste it into surface drawing, right? Why? Because this is in the surface drawing, that is in a different template, or maybe not template at all, in the Civil 3D default template, and we are going to copy it and then paste it into our RDA loaded template. Okay, how we are going to copy? You have to select it like this and like this, edit, copy, right? So wait until the cursor comes across like this. Okay, shall I do it again? Check here, select this way, select that way, and then edit, copy, and wait till the cursor comes back to this cross line. Then you switch into surface file and you can save, edit. Don't just paste as you are doing in your say structural assignments or architectural assignments. I don't know whether you are having any, but if you are having, you can paste them anywhere, but don't put just paste. You put it, remember this very well, paste to original coordinates. Okay, paste to original coordinates. Now wait till this cursor comes back to the cross. It is here. If it is not coming, what you can do is you can just put Z enter, that is zoom command, E enter. Hello, can you hear me? Hello, can you hear me?
Yes, sir, we can hear you.
Yeah, sorry, there is a power cut here, right? So, but anyway, what I did was I have some simple arrangement at my home. That is how I did. I think the power is coming back at 9 o'clock. But we'll try to cover whatever that's possible until I have that power source. So, we were here.
Recording in progress.
Right. Then, so you know, we have pasted our uh, the service drawing. Okay, we will save it. Time to time you will have to save. Understood? The reason is, you know, this is a big software. Sometimes it is going to crash. Okay, so and there are some good practices in Civil 3D. One such practice is to close whatever unnecessary files. That is also to avoid crashing. So I will close this example survey drawing, right? We don't save anything there. Why? Because it is the surveys drawing and we do not have any right to do any changes there. Okay, now you know, these are some points. Okay, so this is the point name, and there is a point number, and there is this elevation. So these are not necessary because we have this in our Excel. So we are going to switch off these things. How we are going to switch off? You select one and see that is text HG. So you can just switch off. And we'll select this. What is this? Text PN. Okay. So we are going to switch off that as well. And this one, that is text SC, we are going to switch off that as well. Switch off or freeze, both are okay. Right? Now we are having just the surface drawing. Understood? Just the surface drawing. Now please remember, before going further, now when we are going to create a surface, that is 3D modeling of the road. Now we have the surface drawing and now we are going to 3D modeling. We want 3 lines. What are these 3 lines? One is center line, other two are the both tie edges, tie edge LHS and tie edge RHS. Understood? So here this is our center line. Now check whether it is continuous. No, it is not continuous, right? So what I do is I am going to make it continuous. How can you make 2 lines continuous? Using the polyline command, right? So what I am going to do is I am going to select these 2 and I am going to make them polylines. Okay, this is not Civil 3D, right? These are just some AutoCAD stuff, right? So there is one easy method in Civil 3D. You can right click and select select similar. Here both are selected. So please understand, I want this line separately to create my surface. That is why I am doing this. Okay, and then check, this is tie edge line. Okay, tie edge line, these are coming in segments. So I am going to right click and select similar. Now check whether your tie edge and center line both are selected. It's not selected, can you see? So I'm going to select another one and I'm going to right click and say select similar. Okay, now check whether everything is selected. It seems like everything is selected. Okay, if it is not selected, we'll have to select them again, right? So after that, what I'm going to do is I right click, isolate objects and isolate selected objects. With this one, what I am going to do is I am going to isolate the center line and 2 tie edges. Okay, here you can see I have isolated both the edges and the center line. Now there's another thing I have to tell you. To create Civil 3D surface, you have to have a continuous center line and two continuous tie edges. So can you see that this tie edge is not going to be continuous, and this tie edge is also not going to be continuous because I am considering this rod, right? Because there is no line like this, so these are not going to be continuous. I want to make them continuous. How I am going to continue them? If I select this one, you see it's a polyline, right? So I am going to explode it, and I am going to draw a line from here to here, and then I am going to make polyline these two lines. Understood? So we'll explode. There are tools for these things, but I am used to type and do. That is what I am doing. If you know what is the explode tool, use that, no harm. Okay, explode, select objects. I am going to select everything, press enter. So now you can see this should be exploded. Okay, so to avoid this line becoming a polyline, I am going to delete one small segment there. And to avoid this line becoming a polyline, I am going to delete a small segment there. After that, what I am going to do is I am going to draw a line from here to here. How you can draw a line? Here you can draw a line from this tool, create line. Otherwise, as design engineers, what we really do is we just put L, that's the line, enter, and width of snap on, you can select here to here. Okay. Then maybe you may be wondering, this man is just telling everything. He is not giving us any notes or whatever. No, I am going to give you a note. I am going to give you a small booklet that I have prepared. So maybe your batch rep or somebody, he can send me an email or WhatsApp me. At the end of the lecture, I'll give the details. So what I am going to do is I am going to give you that booklet for free. So don't worry, it's there in the book, but so just pay attention what I am doing, right? Then now still we have not touched any Civil 3D stuff. We are still doing AutoCAD stuff, right? So next thing what I am going to do is I am going to make these three lines polylines. For that, you have to flatten them. What do you mean by flatten? Flatten is you are going to bring everything into the zero layer. So what I am going to do is I'll just write down the command flatten. I press enter. They say select objects. So I am going to select everything and press enter. So they ask remove hidden lines and no is selected. Just press enter. So now everything is in zero layer. If you want to check, you can just select one, press LI and enter. That is list command. You can see that Z is 0. Okay. So after that, we are going to give the regular polyline command. What is the regular polyline command? Making line segments into polyline. That is PE enter, P edit, polyline edit. So they say select polyline of multiple. So multiple is highlighted. This should be multiple. You know why? Because we are going to have lot of segments. So it should be multiple. So we just press enter. Press M and enter. Right? Then select objects. So I am going to select everything like this. Okay. And then I am going to press enter. So they ask convert lines, arcs and splines to polylines, yes or no. So yes is selected, we press Y, enter. So it says this operation may take a long time to greatly improve performance. The system can disregard raw order. Disregard raw order for operation. You can just give yes. It doesn't have any effect. So it asks enter an option. We have to give the join option. Right? Then enter first distance, that is 0. So that is the selected one. Press enter. Now can you see that a polyline is being created? Right? Press escape. Now you can see this is a polyline, but there is a problem. Can you see this is not being joined? So what you can do is, actually it has to, but it was my mistake that it has not come to the proper point. This is okay. RHST is okay. Then the center line one, it's okay. That is a line type, not some segments. So if you have a problem here, what you can do is you can drag it and put it here, and then again you can go to PE command. PE multiple M, select objects, select this line and this line, press enter, enter an option, that is join J, enter, first distance is 0, enter, and again enter. Right? Now you can see it has become a full polyline. Understood? Then save the drawing. Okay. After making these 3 lines polylines, you can take back whatever that you have hidden. Right click, isolate objects, end object isolation. Okay. Now I am going to import the points into this file. Okay. Yeah, I have to share. Where is this one? Yeah, now can you see there is this example points PENZ XLX. So I am going to open this. Can you see this Excel software? Excel file?
Yes, sir, we can.
Okay. So now you can see it is so here is written point number. It is point number, right? Point number, position X, position Y, and position Z, right? So please understand, in Civil 3D we don't use X, Y, Z. Instead we use E, N, Z. You know, X is east in, Y is north in, and Z is Z. That is the elevation. So what is our format? P, point number, that is P, and then position X, that is E, position Y, that is N, and position Z, that is Z. So our format is PENZ. That is what they have given here. Example points PENZ, right? So you know, we cannot import an Excel file into Civil 3D software. You know why? Even though in Sri Lanka we use only Excel, in other countries they use many other software now. I remember in Linux, they are having something called OpenOffice. So maybe you know, they are having some software called Calc or something. I don't remember very well. In that case, of course, you know, it was around 15 years back I did IT, right? So now I don't remember this in the new versions. At that time, that was Calco, Metro, whatever, I don't remember. But anyway, that is quite similar to Excel, but that is not Excel. So since that Autodesk and Microsoft is not having any agreement between them, they cannot ask others to use only the Microsoft products. So what they are going to do is they are going to have kind of a common platform called CSV format. Okay, CSV format, right? So you have to convert this Excel into CSV format. Before that, you have to remove these unnecessary text. It should be only the numbers. That is why I told you before deleting, okay, before deleting this row, remember the format. Now, of course, the survey has given PENZ, but if he has not given, so you have to remember PENZ. So remove this row, delete, and you go to the bottom of the file and check whether he has put his signature here. Here he has put the signature. So you have to remove these rows as well. Okay. After that, you are going to save it as a CSV format. File, save as. So you can go to your required folder. Can you see the save as dialog box? I don't think. So please answer me, right? So can you see the save as dialog box?
Yes, so we can see.
Yeah, you can see, right? So here you have to select save as type CSV comma delimited. Here CSV comma delimited. So the file name is example points PENZ CSV. Now look, that extension is coming CSV. So you press save. Then they ask, some features in your workbook might be lost if you save it as CSV comma delimited. Do you want to keep using that format? Give yes. And then you can close this Excel file. Right? Now you can see, in addition to this example points PNZ XLX, there is another file example points PNZ.csv. Now if you open it, you can see it is just the numbers, no texts. Understood? So before continuing, you will have to close this. Remember, before continuing, you will have to close this application. Why? If it is open and you are going to import that CSV into Civil 3D, what happens is there will be a sharing violation and it will not be open. Now you know, before this corona thing, actually I did lectures in Moratuwa, coming to the university itself, so in the computer lab. Okay, so at that time the biggest problem the students are getting is, of course, they cannot import that file into their Civil 3D software. Okay, so why? The problem is that it is being open somewhere, so there comes a sharing violation. So remember, as a rule of thumb, it has to be closed. Okay, now come back to your surface drawing. Okay, come back to your surface drawing. Now it's there. Now I am going to import that CSV file into this file. Okay, so for that there is something called points here. Points. If you drop down it, there comes point creation tools, right? Then there comes a dialog box, create points. Here at the end of it, there is something called import points, right? So if you click that, there comes a dialog box, import points, and then you here before browsing you will have to select your correct format. What is your correct format? PENZ comma delimited. Okay, otherwise what happens if you selected PNEZ comma delimited? What will happen? It will come to the third quadrant. Okay, now if you are drawing in the first quadrant, it will come to the third quadrant. Why? XY are changed. Okay, now browse using this plus mark, browse into your file. So here I have saved in desktop and UOM example points PENZ open. Now this is how it's coming. This is the point number, this is easting, this is northing, and this is point elevation. Okay, so you have to click this add points to point group and you have to give a name. If you just click it, you cannot do anything. You have to press this system button. Okay, system like button, and there you can give a name, say topo, that's to say topography, and press OK. So do not click here, do elevation adjustment or do coordinate transformation or whatever. If they are clicked, you have to unclick them. Actually, if they are checked, you have to uncheck them, and then you have to press OK. Once you press OK, your points will be imported into the Civil 3D file. Right, so you can switch off this dialog box. Now can you see that they have been imported, right? The points are being imported. Okay, now save the drawing. Then we can create the surface. Okay, we can create the surface. How we are going to do that? You have to take your tool space using general tool space. So the tool space will come. If it is gone, of course then you can get from general tool space. Okay, and you should come to this prospector tab. You should come to this prospector tab. Okay, and here in this prospector tab there is something called surfaces. You right click on that. Oh, surfaces, right click, create surface, and give the name as EG, that is existing ground. Okay, and then press OK. So if you expand these surfaces, here is the surface that you have already created, that is EG. You expand that, and there is something called definition. You expand that also, and there is something called, see here, point groups. Okay, point groups. You right click on that and press add. Okay, and then select what is this topo, the point group that we created using the surface data. select topo, apply and press OK. So you can close this, and here you can see this is your surface. Surface is being created. These are some contours, okay. But you see, I'll show you how the Civil 3D is creating this surface. So for that, this tool space, if it is a problem for you, you can close it. At any time when you want, you can get it using general tool space. Okay, then again close it. Then I'll show you how Civil 3D is creating this surface. Okay. So you can select this surface. Just select somewhere here. Right click and go to surface properties. And here in the surface style, you can give contour points and triangles and borders. Press apply and press OK. Now you can see how it is creating this surface. Okay, what it basically does is, now you know there is a level here 18.745 and there is a level here 18.751. What it does is it draws a line from here to here, and whatever the levels in between it interpolates. Now remember these two numbers 18.745, 18.751. So if I take my cursor here, just check the elevation is 18.748. 18.748. So that is something in between 18.745 and 18.751. Okay, so that is how it basically does. But now there is a problem. Okay, what is that problem? There are two problems. Not only one, there are two problems. The problem number one, can you see here? There is a point here, 19.128, and there is another point some 500 meters away here, 18.731. Now this silly software is interpolating in between these two. Is that correct? No, that is incorrect. Why? Because we have not taken points here, so you cannot interpolate from this end to this end. So you have to remove that. So what we are going to do here is we are going to give a boundary. We'll draw a boundary like this, and we'll ask, okay, just draw your all the lines inside this boundary. Understood? So these lines will be gone. Then the next problem. It will take little bit time to explain. So just think that I'm going to draw cross section of a existing road. Maybe it's like this. Not to scale, right? Now this is a cross section of a existing road. Now you know this is LHS TAH, right? And this is the center line, and this is RHS TAH. Okay, so these are the turning points. Understood? These are the turning points. So if I want to properly, I'll draw a line here. So it will be very much clear. This is TAH LHS. This is the cross section, right? This is the cross section I'm drawing. I'm just drawing three lines. Center line and TAHS, sorry, TAH RHS, right? If you really want to model this, you have to take all these turning points. Okay, but just think one surveyor a lazy surveyor, he will be taking points like this. These are the points that he is going to take. He will take this point, he will take this point, right? And he will take, say, this point, and after that he forgets to take this tie. Instead he will take this point and say again this point and this point. Now Civil 3D models everything depending on the data that is given to it. Okay, now if you just think how it's been modeled is it's like this. It will catch this point, this point, this point, this point, and this point. Now this pink color one is the actual one, and this the green color one is the modeled one. Can you see the problem there? Now you see here we cannot properly model the tie if he has taken points like this. So understand the problem now? If he has taken points like this, we cannot properly model the tie edges, right? So now we cannot correct all the problems, but we tell the software one thing. What's that? We will say definitely you have to turn here, here, and here. This is tie edge LHS, then the center line, this is tie edge RHS. So we ask you have to definitely turn in this point. So I'm going to draw lines like this. Tie edge LHS, tie edge RHS, and tie edge RHS. Tie edge LHS, center line, tie edge RHS. So once I ask the software to do like this, it will draw its line like this. There is a point. I'll take that. There is a point. I'll take that. My other point is here, but when I try to go there, there is a constraint. I have to touch this point definitely. So I'll touch here. There's my point here. Then I'm going to go this way, but there is another point. There is a constraint that I have to touch this point. So I'll touch this point and I'll touch this point. Right? Now this is quite okay compared with the earlier one. Okay, because at least it is touching this existing road, because it's a kind of the existing road project. So at least you have to model your road properly, let alone these things. Okay, so I'm going to delete this. So that one, of course, we can say in English, but the problem is we have to tell that to the software in the language it can understand. So there is some concept called break lines. Okay, so we are going to make this tie edge and this tie edge and this CL into break lines. So once you make them break lines, there will be no lines like this cutting the center line of the tie edge. Okay, because they cannot cut. Cutting means it is not touching this point. Understood? Right, then we'll do that. So we'll go to general tool space, and there this is our existing ground. Here the definition, and we are going to add, I'm going to add the center line as a break line. Break lines, right click, add. So you give the description as CL, and this type should be proximity, and I'm going to press OK. And it says select objects. Now check, I'm going to select this yellow color lines. Once I select this one, what will happen is these lines will be diminished and it will come along this yellow line. Okay, I'm going to touch, pay attention, and press enter. Look what happened. Now if you check, you will not find any line that is cutting this center line. But still, here there are lines cutting these tar edges. Okay. Now what I am going to do is, I am going to make them also break lines. I am going to add another break line, add TE, tar edges. The type should be proximity. Press OK. Select objects. I am going to touch, say, this tar edge and this tar edge, and I am going to press enter. Check once I press the enter, these lines that are cutting these two lines will be diminished. Now you will not be able to find any line that cuts the CL or cuts the tar edges. So that problem that I described earlier is now solved. Our next problem is this problem: unnecessary exaggerations or extrapolations. Okay, so what I am going to do is, I am going to draw a boundary. Now to draw this boundary, better you or snap off. Okay, I am going to make it in a polyline. So I am going to I'll select some thick line, and I am going to draw a polyline covering the required area. Okay, like this. Since I want only the main road, I am going to cut my surface here. Okay, and then I am going to press C and enter. That means to close the polygon. C and enter. So the polygon is closed. Okay, so after that I am going to add this. Now you can see, if I select this one, it's a polygon. Okay, I am going to add this polygon as a boundary. Once I apply polygon as a boundary, what happens is that surface is going to be restricted inside this polygon. So in boundaries, you right click and then press add. So the name is, say, BD, type is outer. You untick this non-destructive break lines, and mid ordinate distance you have to give as 0.001, and then press OK. So you have to select this polygon. Now check what is happening once I select this polygon. So your surface will be restricted within the polygon, right? So this is what you have done so far. Now your surface is created and it's been corrected. Okay, so you save the drawing. Right, now after that there is one thing that I have to do. What is that? I have to save this in XML format. So what do you mean by an XML format? You know, this is just 1.5 kilometers. Okay, this is just 1.5 kilometers. Now for 1.5 kilometers, this may be, say, 5 MB or 10 MB or whatever. But if you are going to just think that you are going to design an expressway like Ruanpur Expressway or Central Expressway, so there are so many points, and the length is very high, say something like 20 kilometers, 20 kilometer section, or 40 kilometer or 50 kilometer section, like that. So your capacity is going to be very high, so you can't handle. Okay, so what we do is, we are going to make this into XML format, that is kind of text. Okay, it is just text. So then you can say email it, or you can share among your friends or your colleagues or whatever. Maybe you are working here in Colombo, the other one is working there in Jaffna. Within everybody you can share using internet. After that, once you get that XML file from your friend, you can open it or you can import it into AutoCAD, so sorry, Civil 3D. So then what happens is the Civil 3D software here is going to interpret what is there using the text file. Okay, it is just like maybe you have heard what is the web browser. Now nothing is coming. I mean, your web page is not coming from America. What happens is they are sending here some signals, and depending on these signals, your web browser is interpreting what is there. Okay, the same thing we are doing here using XML. So I'm going to select this EG and right click, and you go to export land XML, and yeah, services EG. You are going to press OK, and you go to your required folder UOM, and you are going to save it at surface XML. Right now, if you go to your folder, you will see there's another one called surface XML. Now whatever that you have to do with your Civil 3D file for the surface creation is finished, so you have to switch off that. I'm going to save this, and I'm going to close this. Right. Now you see there is something called surface XML. Shall you open it and see what is inside? Now you can see this is just a text file. I believe you can see this, right? If you don't see, please tell me. Now you can see they have defined the boundary here, boundary type, outer edge, whatever, and there is a they have shown the break line CL. These are the coordinates, and there's another break line TE. There's another break line TE. After that, the points are given. So that means everything is restricted into text. So in another Civil 3D file, you can interpret it without any problem. Okay, and now whatever that we have to do with surface is finished. So now we are going to do the alignment. Okay, so we'll again open another Civil 3D file. Civil 3D 2018 metric. Okay, now this is our Civil 3D default template. Now you know what is the first thing that you have to do. We are working in our RDA template, so you have to load it. File, new, here UOM, HO, you open it. The usual error messages are coming. This drawing was last saved with an earlier version of software. Close it, and there's this blah blah blah. Continue with the current command, and you save it as, go to your folder, and save it as alignment. Right, now you have to close down this unnecessary default template. Okay, and then I'm going to import my created surface here. Okay, I'm going to import my created surface here. File, import land XML. Now if I go to our required folder, UOM surface, and press open. Okay, then this one, import land XML, these are the things that are going to be imported. Press OK. So this is the surface that we created. If you have any question whether this is the same surface that has been created, now what you can do is you can select this one, right click, go to surface properties, and here surface style, change that into contour points and triangles and borders, and press apply and press OK. Here is your surface without any change. Okay, just think, you created your surface in Colombo and you sent that surface to your friend in Batticlo. Okay, now here in Batticlo he is opening, so this is the exact surface that you have created. Okay, after that we have to copy the surface drawing and put it here. So we can file, open an example survey drawing here, press open. This one again come in because the survey has done it using some other software. So continue opening DWG file. And one thing you can do is, if you want, you can switch off these things here itself before taking that into your file. Okay, so this tool space is not necessary for the time being. We'll switch off it, and you can select this one, that is TextHG, switch off, and this one TextPN, switch off, and what is this one, TE TextSC, switch off, and there are some balls or circles, point SN, switch off that as well. Then this is what you are going to copy and paste. You can just copy, select like this, edit, copy, wait till your cursor comes to the cross, and then switch into alignment. Okay, and now you can paste, edit, paste to original coordinates. Right, now your surface drawing is there, your surface is there. Now what you are supposed to do is to create the alignment. Okay, to create the alignment, save the drawing, right? Save the drawing, and a good practice is what you have to close whatever unnecessary files. So I'm going to close this example survey drawing, but I am not going to save anything because we cannot do any changes in the surface drawing. That's a problem, right? Because you get the surface drawing, after a while you do some changes, then you know what is your original file or whatever. So keep it as it is, don't change anything, right? Right, now I am going to create the alignment. Now I believe that you have learned the basics of highway design and the basic theory, right? So our usual theory is, our basic theories, we are going to design an alignment using straights and curves. Now usually in national roads we do not use spirals, only in the expressways we use spirals. Why is that? Because what is the design speed that we are going to design national roads? It is either 70 or 50. Why? 70 is in rural areas and 50 is in
Recording in progress.
Can you hear me? Hello?
Yes, sir.
Ah,
We
right.
can hear you.
Yeah, the problem is, I have a power cut here. There is some 1 hour and 20 minutes power cut. So I'm having the electricity with the battery. So that is why there are some disturbances are coming. Sorry for that, right? So, you know, now here, yeah, what we were talking about was about alignment, right? So in the alignment, usually we use either a straight and curve, right? So you have to use you are using uh, you know two straights and connected by a curve. So our usual design speed in national roads is, it is either uh, 70 kmph, or it's or 50 kmph, because in rural areas it is 70 kmph, and in in what you call the urban areas it is 50 kmph. So what is the normal speed of an expressway in Sri Lanka? It's usually we go from 100 kmph to 120 kmph. For such kind of higher speeds, you have to have spirals. Otherwise, the driver cannot, get his proper spiral curve. That is why we use spirals, right? Okay, then we don't want this surface for the time being. Of course, we want this surface to design the alignment, but for the time being, we don't want. I'll tell you why we want this surface when you want to design this alignment. Now, remember one thing in our first assignment. Okay, in the first assignment that we give the surveyor to do a topographic survey, he is taking levels using uh, total station. Are these levels correct? Yes, please answer me. Are these levels correct or not? So you have no idea. What is the problem with the total station levels? Yes, guys, please answer me. Yes, what is the problem with these total station levels? Are they, at least do you know whether they are accurate or not? Ah, yeah, they are not very accurate. Yeah. So you have to speak, right? Because the problem in these countries, engineers do not speak. Right? That's the problem. Please speak. Right? Yeah, yeah. We say, okay, they are not very accurate. They are not very accurate. Why? Because we are going to get the instrument height, we are just giving very roughly. But they are very much okay for our alignment design. Why? Because highway design is a different thing. It's not structural design. So what is the accuracy that you want to have in structural design? Maybe 1 millimeter, 2 millimeter, or something like that. But in highway design, even 5 millimeter and 10 millimeter are okay. If you are going to decide whether your alignment should go to the mountain or the precipice, okay, whether your alignment should go to the mountain side or the precipice side, to decide that 5 millimeter or 10 millimeter accuracy is okay. But when it comes to the payment for contractors, of course we are going for 5 millimeter accuracy, right? That is true. But to decide, now you see, if I can check here, if I can check now just think, this side is precipice, right? This side is mountain. Just think it is a mountainous area. If I want to decide whether I should take my alignment here or there, then this total station levels are also sufficient for that. If you really want, you can draw a line here. I'm going to draw a line here, and I'm going to check the cross section here. How? I select it and then right click, quick profile. Here you have to give the profile view style as this RD style. Press OK, and you can put it somewhere here. This is how that road cross section is coming. So with that, with the experience, you can check whether your alignment should go there or there, here or there. Okay, that's possible. That is why we create our surface in this very first instance. There's another thing. Sometimes, now of course, if you want to have accurate levels, you have to get the points using the leveling instruments, right? Sometimes we don't do that in the design stage. We are just giving our profile using these levels because that is pretty enough for the tendering purposes. Now as I told you, even 1 inch difference, say 1 inch is 25 millimeter, right? So even this 1 inch difference is okay for for our work, right? The problem is when it comes to tendering. Of course, the contractor has to have a level line with the client, and then only with these levels we are going to design the profile. But for the tender documents, even to design the profile, these levels are pretty okay because it should not be perfectly accurate. So that is what you call, now we do a project and we prepare an engineer's estimate. So engineer's estimate is not very accurate. It's just the rough values. It's just like, traditionally it is just like asking an engineer how much we are going to how much we will have to spend for this. So he's telling a value that need not to be very accurate. Okay, but it is kind of some approximation, right? I think now you understood. So we'll go to design the alignment. Before that, I have to tell you one thing. If you are going to design the alignment, you have to understand for each of the design speed with some particular super elevation, what should be your minimum radius. Okay, I think that you have studied these things. We'll see whether I'm having this one with me. Please give me a second, right? Can you see this horizontal alignment? Here, this is that table, right? Just think that I am going to design for 50 kmph. If I am going to have 2.5 super elevation, it should be 105 meter radius. If it is 3%, it should be 100. If it is 4%, it is 95, right? And then say I am going to design for 70 kmph. If it is 2.5 super elevation, it should be 225, 3% 215, 4% 205. Yeah, beyond that we usually don't go in flat terrain. Now our RDA book is telling that for the flat terrain we can go up to 6% super elevation, but usually we don't go such high values. In national roads we go only up to 4%, right? Yeah. Now right, now we'll start our alignment, right? So for that we'll switch off this surface properties, no display, right? Now there is a bridge. This is not continued, but what I can do is I can just draw a line here from here to here, and then I can get the mid center of that, say mid of here, and I can join it here. So this is the line that I have to draw. Okay, now please pay attention. I am going to draw the alignment. Okay, so there is something called in this menu alignments. So you can get alignment, create alignment by layout. Okay, and then you give a name, say DCL, and this type should be center line. Starting station is 0. There's a site, say site 1, but if it is not there, you can create a site here. Okay, site, so you can use say site design. Okay, apply. Okay, site design. Alignment style is RD design style, and alignment label set is alignment stations EN1000. Press OK. There comes a toolbar, right? So you know, please understand, in Civil 3D this is nothing about design, right? In Civil 3D you have to start an alignment either using a fixed line or a fixed curve, either using a fixed line or a fixed curve. Understood? So I'm going to use here now, depending on this one, I'm going to use a what? This is a line, right? I'm going to use this fixed line here. This is the line, fixed line, 2 points. Okay, so I'm going to start here, and I have to keep it to match with the existing one. Okay, now you can put it even here, and then later you can shorten it. Okay, no harm. So I'm going to put it like this. Later you can change, right? And press enter. So once you put this line, you see the changes are coming automatically, right? Now after that you have to check here, this is kind of a straight. Okay, this kind of a straight. So one thing that I propose is, before going for Civil 3D, you can draw a line connected from here to here and check how your line should come. Okay, so I'll draw a line like this here. This is an art, right? Ouch. Or snap off. So you have to match with the existing line, right? So it is coming this way. So we'll take our alignment back to this point. Okay, then this is the first method I'm going to tell you. I'm going to teach you. That is the first method. So that is here, tangent tangent no curve method. Okay, tangent tangent no curve method. So you go there, and please make sure now, once you using this tangent tangent no curves, so you have to select this endpoint very properly. If it is not going to be joined, it will not act as an alignment, right? So I'll keep it this way. Now here it acts as an alignment, because you see the changes are coming, so it is acting as an alignment. So I can delete this blue color line. Okay, now you see there is one straight line here, another straight line here. This is called an IP, intersection point, right? Now you know, I told you have to know. Now my design speed is 50, right? Because this is a city area, Talduwa town. This is a town area, so my design speed is 50. Okay, my design speed is 50. Now what I am going to do is, so if you want, you can check So for 50, it is better if I can go for 105 radius or above. Or then if it is 2.5 super elevation. Otherwise it is 3% it is 100, 4% is 95. So I have to make sure that my minimum curve is 95. That's 4%. Sometimes there are places that we cannot go, maybe, so we'll have to go one step down. So that means we'll have to go for our design, say 40 kmph. But we'll try here, right? We'll try to give 105 here and see what will happen. So here you can use in this free curve fillet between two entities and radius, free curve fillet between two entities and radius. So you can select first entity here, select next entity there, and it says is curve solution angle greater than or lesser than? That is a very foolish question they are asking. So you know, when two lines are intersecting, one curve is lesser than 180 like this, other curve is greater than 180. Now usually in an alignment we don't use this angle, we are using only this angle, so it is always lesser than 180, right? So then they say specify radius, we'll give 105 and press enter and check what happens. Now this is your existing center line, this is your design center line, so it is coming here, right? So you have to go to the field and check whether this is possible. Maybe this is kind of a precipice, you can't go, so maybe you will have to reduce this one. If you want to reduce, you can get your properties table here, and you can select here. So that is 105. So if you want, you can go to 95, something like that, or say 100, right? You can change like that. So that is your first method, tangent no curve method of creating a curve. Then here I am going to tell you the other method, like a floating curve. I am going to create this curve, floating curve. So here I can take floating curve from entity, radius, through point. Floating curve from entity, radius and through point. Select entity to attach to this one. Okay, I'm going to select the alignment. Specify radius. So you have to understand what is this radius. So maybe we'll say it is like 250. You have to guess, right? Can't say. So it is always solution angle is lesser than 180. And I'm going to try to place it. Can you see that the existing one is greater than 250? If I put it like this, so I can change that radius later. Say I'll put 300 or maybe 350. Higher the better. Enter. This one seems okay. Then what about this? It seems like a straight or a curve. We'll try. That is guessing, right? Floating line. I'm going to get floating line, and I'm going to select entity to attach to. I'm going to select this one, and I'm going to draw a line like this, right? Again I'm going to enter using. Now if you want, the other method you can do is, you can of course draw a line like this, as I did earlier. Okay, you can draw if you want, you can later you can change, right? Here it seems a bit wrong, so you can take it this way and match it with the existing center line like this. Look, it's mostly matched. So then you can extend, draw in a line, you can extend that line. Okay, like this. So this has to be extended. Now if you are not very sure about yourself, about your hand, because if you are not sure that your hand will slip, again you can draw a line like this and extend it there. Okay, so this is the point, right? So what you can do is you can drag it here. Look, after that you can draw another line using tangent, no curves. So you have to select it properly and then you can keep it here. Later you can change, right? So you can delete these lines, and here you have, here you have two straights and an IP. So you have to have a curve here. So we'll try using this curve, free curve fillet. Select first entity and then select next entity. Yeah, it should be less than 180. So our minimum curve is 105. So we'll try this. This is how it is coming. So you can engage a curve greater than 105. So we'll modify it. It's 105, say 150. 150 is the best curve, it seems. So why I am going to match the alignment as far as possible to existing one. Otherwise what will happen now? Just think that I am going to unnecessarily improve. So if I am going to say I am going to put here 250 or something, so these, now these blue color ones, these are buildings, right? So that they will go, then what will happen? They will be lining up in my office next day. Sir, why you are going to demolish my house? Because earlier also it was good, now you are going to improve more. It's not necessary, right? So therefore we are not going to do like that. If necessary only we are going to improve. Now here you see, here if it is if our one is 95 minimum, if you want to have 95 minimum, then of course we will have to improve, otherwise we don't. Okay, then here I am going to design it using my second method, that is using floating curve from entity radius true point. Select entity to attach to, you select this one. So there is a curve, so my minimum curve is 105, so I'll select this one and it should be less than 180. So this is how it is coming. If I am going to put 105, this is how it is coming, right? So you are going to demolish all these things. 105. So maybe we'll try to reduce it into, say, something like 95 and see what will happen. Okay, if it is 95, of course you will have to change that location, because you cannot put a curve like this. Why? If you are going to put a curve like this, you are narrowing the curve here. Okay, so you will have to correct it, maybe something like that. Okay, never put a curve like this because you are narrowing the situation. Okay, then maybe there is another curve here. It's not a straight, right? There is another curve. My toolbar is gone. If it is gone, what you can do is you can select the alignment, right click and get edit alignment geometry. It's coming back, right, without any problem. It's gone again. I think I press escape. Edit alignment geometry, right? So I'll just think this is something like 500 curve. We'll see, I don't know, because it's going to be compound curve, right? In the same direction, two curves. So I'll go to say floating curve from entity radius 2 point. I'll select this curve and say 500 radius. It should be less than 180, and it is asking is curve compound or reverse to the curve before, that is to this curve. It's compound. Okay, we'll see what is this symbol. That means such a curve is not possible. If I am going to put it here, such a curve is not possible, but here it's possible. You see, here possible, but here not possible. Okay, so it perfectly matches. And there is another curve here. This curve, I think it's a narrow curve, but at least we'll try to put 95. It's a reverse curve, understand? It's a reverse curve. Okay, so we'll try to at least put floating curve. So we'll put 105, lesser than 180. It's reverse, and see what will happen. If it is 105, there comes some improvement, and you are most probably you are going to acquire these two buildings. So we have to check whether 95 is going to work. So this is the minimum one. So that is all what you can do, because lesser than 95, of course you can't go because it is not according to our standard. But you know, in extreme situations, maybe you can go one step down in design speeds. That means you can, instead of 50 kmph, you can select 40 kmph. Understood? So here we'll try again. This may be, say, we'll try 105. Floating curve, select entity, and say the radius 105, less than 180. It is reverse, right? Because it is this side and this side is reverse. And this is how 105 is coming. Again, it deviates from the existing center line. So we'll put 95 and check what is happening. 95. It doesn't make any difference. It doesn't make a lot of difference, right? So here this is a straight, no problem. You take this floating line and stop here. Now here one thing you can again do is using my first method, right? So I'll put it here and try to draw a line matching this one, and you have to match, right? So you should have a very proper eyesight. Unfortunately I don't, right? So you can extend. Here, so this line has to come to this point. Okay. And you can use tangent no curve here, and you can stop there. Okay, so you can delete these blue color lines, and there are two straights and there is one curve here. So you have to put using free curve fillet, but remember you cannot put floating curve from entity radius 2 point here, right? Why? Because there are two straights, so you have to put free curve fillet between two entities and radius. Here and here, it is lesser than 180. We'll try 105. So this is how it is coming. So another thing you can do is you can try 95 and check what happens. 95 is fairly okay. Then here there is another curve. We'll try say 95 lesser than 180. Specify endpoint. This is an art, right? So save time to time, right? Otherwise what will happen is if it crashes, everything is gone. Oh, 2045. Is that time okay? Yeah. Right, so I think this is enough, right? So because I want to give you some time to ask questions and everything. And there is another thing we can do. Right, now we cannot just draw the alignment, right? After that alignment is a center line only. After that you want to have say your tie. Say usually we are having no, not the tie, sorry, lane edge, that is 3.5 meters. Okay, so you can just have 3.5 meter both sides, so that is your end of the lane. And then we have another 1.5, that is the hard shoulder. Okay, both sides. And then we have another 2 meter, that is soft shoulder. After that, depending on the requirement, there is a drain. Understood? So one thing we can do here is, if you select this alignment, there is something called offset alignment. So better to use this option. You take offset alignment and offset name template. But if you want, you can give a name, say lanes. Okay, then incremental offset on left, say 3.5, that is 3.5 offset. Incremental offset on right, that's 3.5. Alignment style, you can go to RDA design style, and you don't want any labels. If you press OK, have a look here. DCL, alignment to offset from, that is DCL. This one, offset name is lanes, station range is from start to end. Number of offsets on left, that is 1 meter. Number of offsets on right, that is 1 meter, because there is only one lane we are having. And incremental offset on left, that is 3.5. Incremental offset on right, that is 3.5. And alignment style, the RDA design style, there are no labels. If you press OK, there are another 2 alignments that is coming. Okay, that's lanes, that is lanes 1. So later, if you want, you can change the name here. You go to alignment properties, it is called lanes. Say we'll put that's lane edge now. So DLHS, we'll put it that way. And this one, I'll right click alignment properties, I'll put D, that is design RHS. Okay, now you know why I did it that way. If I select this alignment and I go to alignment geometry and just think that I am going to change this radius, say I want now 105, and once I press enter, other 2 alignments also changes. See, other 2 alignments change. Otherwise what will happen is you have to do it manually, but now it automatically changes. If I take this back to 95, you can see it's going to change automatically. Okay, so this is how we are going to do it automatically. And after that, if you want to showcase what is your alignment properties, there is a method alignments. You can go to add tables, add tables, and you can go to renumber text, right click, press S. We are going to go for settings, line starting number 1, curve starting number 1, press apply and OK, and then you go to alignments, add alignment labels, multiple segment, and you select this alignment. Here you are getting L1. This is the length of the first line, 96.651, and this is C1, radius is 100, and L1 here radius 350, and here radius is 150, here radius 95, here radius 500, here radius is 95, it's 95 like that. So everything is showcased. Okay, save the drawing. So I think that is all I plan to do today. Create the surface and then the alignment. Okay, now please understand, actually we are having 1 second now. Yeah, so guys, please understand that we are having very limited time. Actually, if I do it as a professional course, I'm taking minimum 16 hours to complete the Civil 3D thing. Unfortunately, we have only 4 hours, but I'm going to trying to cover everything as much as possible. So but I want your support, right? So you have to ask your questions if you're having. And any questions so far? Now please speak, right? So don't be afraid. So you are also going to be an engineer. So I also remember that how I studied in engineering faculty. I have studied in Peradeniya as well as Moratul both. So don't be afraid. There's nothing to be afraid, right? You're also going to be an engineer. I'm also an engineer. Only thing is our age difference. Okay. Yes, guys. It's almost 20 years after yeah, almost, no, not 20, yeah, you are in the final year, right? I think so. It's almost like 18 years after my graduation. Okay, but our students are not yet changed. Right, so please send me your one of your email addresses, so I'll forward my small booklet for you to study. I'll put my email address here. So my email address is sunet.tushar@gmail.com, and my WhatsApp is 077 3179 261. So please select one of you. Not all the batch don't send me messages. Okay, so because I have a very poor phone, so it will be filled. Okay, one or two persons, you can send me a message, so then I can send you probably by tomorrow my booklet on Civil 3D, and as well as other materials for you. And this is my number. If you have any questions, please don't hesitate to ask. You can just give me a call. So you better if you can speak within 6 p.m. to 9 p.m. at night. Okay, because sometimes if I am at the office, I will not be able to answer the call. Okay, so please ask the questions, get your doubts clarified, and I think that's the major thing right now, because this is just an introduction. Maybe there may be a lot of questions when we are going to try your assignment. Then only you will remember, okay, it's better if we can ask a question, but I am available for you. Uh, you know, you can use this email address or using my phone. You can ask any questions, right? So if we don't have any questions, then shall we wind up?
Recording stopped.
Yes, guys.
Okay, sir.
Okay, so I think tomorrow also we are having the same thing at same time. The problem is this power cut. Okay, because power goes by 7, I think 7:20 or something. Really difficult, but I don't know. Anyway, then thank you very much. Have a nice day.